Well, all right. So welcome to yet another weekly robotics meetup. Today we have Davide Faconti, who will tell us about CPP optimizations for robotics, but probably not only for robotics.
Okay,
Yeah.
cool.
Yeah, we can get started if you are good to go.
I am. So I guess you can see my screen, hopefully.
Yeah, we can see the screen.
There's Matt, there is a little bit of echo from you. I think
Yeah,
you're the only
I'm
one
muting my.
unmuted. So, okay, great. All right. So, welcome everybody. You know, I've been doing robotics. So a little bit about myself. I've been doing robotics now for, I've lost the count. I don't know if it's 16 or 17 years. So I'm an old guy already. And I've been very lucky. I was able to work on many interesting projects, humanoid robots, mobile robots, industrial, more industrial AGV. And in my career, I really touched a lot of the domains of robotics, just in software. So I even worked in mechanics. So just talking about software, I worked on real-time control, low-level interfaces to the hardware, manipulation and biped locomotion, because as I said, I worked a lot with uh, legged and armed robots, navigation, autonomous navigation and SLAM, perception. So recently I joined a company called Sigrid in the perception team, and high level planning also. That means what we would call task planning. So I'm the author of BehaviorTree.CPP that is getting some momentum in the ROS community. So I like to think about myself not only as a roboticist, but also C++ developer. So I'm very passionate about C++, and in the same way, I usually try to find the solution for my robotics problems. I also find fascinating to find a solution in the C++ domain about creating better software. And better software very often means also faster software. And the reason for that is that very, very often we need to run so many algorithms in our PC. And I've seen many times teams struggling in the integration phase because on their PC, their single algorithm works fine using maybe 6 cores. And then when you put all of them together, of course, you don't have enough computational resources. So when we talk about speed, we are talking about the throughput. That means can I process all the data I receive without buffering? So can I process it as fast as I receive it? And just to make an example, if any of you has played around with the Octomap, Octomap is super slow. I mean, it can ingest maybe 1 or 2 clouds per second at most. So he has a problem of throughput. Sometimes you can solve this using parallel computation, but then as once again, it's not about using less resources. It's about use more resources. So what we are discussing today is how to use less resources if we can. Then there's a latency. That means how long my process will take, how long my data will take to be processed. For example, if I'm analyzing a point cloud to see if there is any obstacle in front of me, how many milliseconds will take to process that information. And there is a pipeline, there is the driver, then there is your agreement, then there is the output. And if any of these steps takes that are in a sequence take too much, then your latency maybe is also too much or more than want you. And then there is closed loop control. So this is even worse if you have a strict deadline that is your loop and you miss that deadline. I had this problem in the past, with my control algorithm for biped robots. There is also then, when you talk about control loop, we start talking not just about performance and speed, but also about real-time operating systems. That is not something I'm going to discuss today. And then what I call the bill of material. Of course, there's this idiom in America that say kill it with iron. I mean, okay, if you don't have enough computational power, just buy a more expensive computer. But I've been, in the industry, not just in research, and when you're manufacturing 1,000 robots, you really want to spend less money on your components. So if you can write in better software, you can use a cheaper computer that is great value, that is a great return on investment. um, and then whenever I talk with this, especially with the younger people, they say, okay, can I run this algorithm in this GPU? No, most of the times you can't. I mean, there are specific algorithms that are good for the GPU. There are specific domains. I mean, even point cloud processing, we have very little algorithm that can be processed in GPU. So GPU is not a magic solution for you very often. Sometimes it is. But in my experience, is not a magic wand that will solve your problems most of the time. So we are talking about optimization that can take place in the CPU, not the GPU. So I decided to give my little, give something back to the community with this. I would call it blog, but it's I think the right definition is digital garden. Uh, Basically, it's a web that I update in a random order where I try to share, my 2 cents, my experience, and some practical example about something I learned in my career. So little tips and tricks to that works for me. So I like to think that there are very simple rules that are actionable. So sometimes, if you look for this subject on the internet, you will find a lot of resources, and sometimes very hard to understand things. So what I'm going to discuss today is so easy that maybe some will be offended. They say, "Come on, David, we know that," or someone else won't. But the point is that very often I found code in production or in a popular open source softwares that don't apply these super simple rules. So even if it's simple, doesn't mean very often I see that people forget about it. Then best practice. So once you learn this, they start becoming best practices, something that you do without even thinking, like washing your teeth, right? Brushing your teeth. And this is good because even if you have sometimes a small contribution, if you're lucky, you have a very clear bottleneck in your software. If you're not lucky, you have what is called a death by 1,000 paper cuts. That means that there's no clear hotspot that can be optimized, but you need to try to gain a little bit of performance in many different places. But having these best practices help you to avoid this small part of your code that take 1% of time here, 1% there, and so on. And I'm trying to mention in the blog. I try to mention also some real pull requests that I did, so you'll see that these are not just theoretical things, but it's something that actually changed the existing software. So I think that is interesting. So let's start with some simple rules. So the number one rule is do not make assumption, always measure. And probably you've heard this recommendation many times, but the point is that whenever I start discussing this with people that knows about my blog, everybody blindly try to say, okay, maybe this takes too much. They say, no, don't make assumption. You don't know if what you're saying takes too much time or too much computation. Measure, because most of the times you're wrong. And something else is that if you're looking at a project and source code that you don't know. So sometimes I didn't know anything about a project. I just measured and found the issue just measuring the specific bottleneck. And I'll show you how to do that. And this means that I don't need to learn 3,000 lines of code that I've never seen before, because I have what is called the smoking gun. I know exactly where is the part of the code that need some kind of intervention. As I said before, the more you do this, the more you will learn your own rules and best practices, what I call design patterns, and you will start applying them by default in your code. And then it's also important to remind that the number one feature for source code is readability and maintainability. So don't try to be too clever unless you really need it. So sometimes it's better to keep your code simple and sacrifice a little bit of speed if the alternative is to make your code super complicated. Even if, in my experience, I've never seen a situation that really required to make your code uglier. But if you find yourself in that situation, you want, first of all, code quality, readability, and maintainability. Okay, let's talk about tools. So I realized that in the last years that using the right tools makes a huge difference. And when you don't use these tools, your productivity goes down very quickly. So the number one tool that I always use is what is called perf. That is basically one of several ways you can profile your applications in Linux. Is probably the one that has the most flexibility. So basically perf will attach to one of your processes and make sampling. So it will periodically look at where your execution is and create a statistic. So say, okay, you're spending 20% of your time in this function. And then, so what you can build from it is what this graph that is called a flame graph. So a flame graph give you the hierarchy of the from parent to child of your calling tree. So for example, here, I hope you see my mouse. Here, I see that the receive loop of this library takes a lot of time. And this time is split between can receive driver and receive message. And so I said, okay, this chunk seems to take something like 25% of the time. And if I go further, I said, okay, this is spent in this unordered map access. And then I said, okay, I don't need to look at all the code. I just need to focus on this chunk, because if I can't fix this, then I'm already having a huge benefit just without changing my code everywhere. And maybe there's something else that said, oh no, I think this function is slow, and then in reality it isn't. So sometimes you are really surprised. Something I also want to mention is what we call intrusive profilers. That is basically putting code, using libraries like this one I mentioned, Easy Profiler. You can put in your code some, a line that will create a log. So basically, you have to modify your code to introduce the profiler. They are great, but I find myself using perf much more because it's not intrusive. You don't need to modify your code. You just need to build it with debug information, so release with debug information, and that's enough. And I strongly recommend you to use Hotspot. It's basically a graphic user interface for perf. You will love it, and it's the one I use. Then the second tool I recommend is Google Benchmark. There are other libraries, but this is probably the most common. You can also run it online, so you don't need to compile anything on your machine. And whenever you have a small chunk of code and you want to benchmark, it is a great alternative. So in this example, we can see that basically the cost of creating or copying a string, the creation is much faster than the copy. Then we can discuss why is that, or what for me is interesting is that sometimes something that I think could be very different is not. So the benchmark can surprise you because something is much faster than something else, or because it's not when you think it should. So I think it's a great tool to test, very small portion of your code. And then something else. So the first tip I'll discuss is avoid memory allocation and beware allocating memory in the heap. So the best tool to analyze heap allocations is heap track. I really recommend you to have a look at it. It's much better than Valgrind, if anybody knows that. Doesn't slow down your application so much as Valgrind. So it's a tool that also I use sometimes. Okay, so let's move now on more actionable example. So the number one is avoid memory allocations. This is particularly important for real-time software because memory allocation is a non-deterministic operation in many cases. But I found practically that very often memory allocation may take 10, 20, 25, depends, percent of your CPU when it's not needed. And so sometimes you can allocate a certain object only once and reuse it after a clean, or maybe you need to use a different data structure. If you think about it, STD from the standard library, STD list works basically allocating any single node of the list. There's no other way. Instead, if you know a little bit about the internals, a vector usually has a single allocation unless you reach the total capacity of your vector. In that case, you vector double the memory to avoid allocating once again. So for example, if your capacity is 100 and you try to push the element 101, the capacity jump to 200. And actually, that's kind of funny because this graph now, you can recognize that this was a vector. So this was a vector growing, and you can recognize because it's doubling the consumed memory after a while. It's exactly the double. So when I saw this graph, this was in a project I did my last job. I said, okay, this is a vector that is growing out of control. I need to find which one it is. So it's very easy to. But so in general, you want to, if you can't avoid, for any reason, you can't avoid creating small objects very often. Consider using a memory pool. So these are just two examples. I think it's very interesting if you want to read how to implement if you just Google how to implement a memory pool in C++. I think it's interesting because sometimes just a simple data structure can be used as a memory pool. But anyway, in my practical experience, I've never needed to do this because usually the best strategy is to avoid basically avoid the creating in the heap altogether, or do it only once. So something that related to what I just said is your favorite data structure should be vector. Vector is very fast to iterate, it's fast to create, you have random access. Of course, there is limitation. We'll discuss it later that you cannot do pop front. So, but in general, the point is, if you can use it, of course, there will be situations in which you can't. But I always think, can I use a vector here? If you do, remember to do reserve. That is basically what I mentioned earlier. Is a way to allocate memory only once and not multiple times. Here you can see how this piece of code, how much CPU it takes if I use or don't reserve. So now one of those practical examples I promised you. Actually, there is a pull request I sent to the RealSense GitHub repo. I was, I was benchmarking with the hotspot, my RealSense driver, and I saw that 20% is huge. 20% was spent creating this list. So I said, okay, let's see. Let's have a look at the code. And this was created in every single frame. So it means if it's 30 frames, it was created 30 times per second. And the solution was say, okay, no, I'm not going to create a new one. First of all, I'm going to change it to a vector. And then, because there's no reason to make it a list, no reason at all. It's just, and then I create it only once and reuse it instead of creating it every time. And that was a 20% improvement in CPU, just this small change. And if you think about all the operation done by the RealSense, I mean, the RealSense driver does a lot of operations. There's also filtering of the point cloud, the conversion from image to 3D. And so it's really surprising that something so stupid could take 20% of the total computation. So you have the link here if you're curious with more details and the actual link. Then something else I recommend you to consider if you find yourself in this situation in which you have a vector that is probably small, that means, I don't know, 10, 5, so small number of elements. You can use something that is not in the standard template library, that is usually called small vector. There is basically a data structure that has some capacity that is allocated in the stack. So memory stack is fast, memory on the heap is slow. And so I'll say, okay, if you allocate less than 10 elements, it's going to be super fast. And if you have 11 or more elements, then we fall back to the usual implementation. So it's not going to be worse than a normal vector, but in many cases it's much faster. So you have just to mention some. You have here 3 possible implementation. I suggest, if you like programming, I suggest you to write your own. It's a good way to practice. It's a very simple. So once you understand, maybe looking at this code, how that works, it's kind of funny to, as a weekend project, to write your own. It's not even a weekend project, maybe just a few hours. And in general, so try to avoid the STD list. And if you really need to have a kind of first in, first out data structure, you can use DEC, that is a good alternative, or Boost circular buffer. As you notice, I always mention Boost because maybe it's not the nicest library, but it's for sure a dependency. If you're in robotics, it's for sure a dependency you already have because of ROS. So you don't need to pull once more yet another library into your dependency tree. So if always look at Boost. Boost has some is so big that sometimes it's hard to even know what they have. So tip number 3, associative containers. So of course there are cases in which you need an associative container. Usually map is not very good. I mean, there could be some cases in which the number of elements is very small, or the comparison function it's very cheap, in which it's the fastest solution. But unless you really need it to be ordered, always default to an ordered map. It's usually the good default to use that will not betray you. Sometimes I think this is interesting. Sometimes I don't even need to have a real associative container. I can use something like this, a vector with a pair that is key value, and then I can sort it with any algorithm with std sort. So if I want to have access to a particular key, I can use log n search. So it is from a big O perspective, it's as complex as a STD map, but it's much more memory friendly. And if you need to search for a certain element, it's going to be slightly faster. But if you need to iterate through all the elements, if you have a for loop, it's much faster. So sometimes think about it. This is an option that for me worked a few times. There's also this other container that you might want to try. That actually it's basically it's really similar to in terms of memory layout to what I just mentioned, the STD vector, but you have a more familiar API. So, but the idea is that whenever you see, and you need to measure this. So if you see that your associative container takes too much computation for any reason, try different options. There are also other options, open source that claim to be faster than the STD library, STD unordered map. So if you really find that to be a bottleneck, you might want to try another library. There are many. Example, that's a contribution I did to the Velodyne driver. And I was very proud of that. That's another example. Basically, they had a table of what they call the calibration table. So for each of the rings of the lidar, there was a different angle calibration. So they needed to access that, and they were using a map. But they are doing it for each single point of the point cloud. There was a lot of points, and accessing a SD map is slow. So basically, what I did was pretty simple. Once again, you can go to this link to see the details, but it was basically converted to a vector, and once again, this something so simple really had a big impact in the performance. Number 4, we're going fast. I think this meetup is going to be slow, to be short. So don't compute twice if you don't need to. So very often you will find situations in which maybe you are computing multiple times the same results, and you realize that you can save the previous result and use it again. Recently, I can't. Unfortunately, this is still under development, so I cannot give you many details. But this is one of the tricks I'm using recently to speed up an algorithm I'm working to. That is basically finding the opportunity to use the last computation I did already, and if I can't, I'll compute the result, the intermediate result again. Otherwise, I'll use it. And this now we can see some code. So I think this, if you're familiar with laser scan, you know that the laser scan message is expressed in polar coordinates. So you have an angle and a distance. And usually you want to convert it to Cartesian, so XY coordinates, to make sense of it. And a way to do this is to create a lookup table where you save an expensive operation. So in this case, the expensive operation is cosine and sine. So this is something that if you compare with a multiplication, is much more expensive. And it doesn't change because usually you have some constants that happen to be always the same. It is the angle increment and the angle minimum. So if you're not familiar with laser scan, probably you don't know what I'm talking about. But the point is that sometimes you can use lookup tables to avoid repeating the same computation over and over again, and this has a huge impact in the speed. This is another example. This is exactly the same flame graph I showed you earlier, and as I told you, yeah, I'm really unhappy. I mean, this is another map access. This is the find operator. Is this is all the places where it's wasting my CPU. And I realized, look at the code. I realized that all these, this on the left side were really hard to it could be different every time. But the one on the right were always the same. So it means that a certain object would always have, for the lifetime of the application, the same value. So I could save the result. I could save the result of the first search, and all the other times I would just use the previous result. So basically, this entire chunk of computation just disappeared overnight, and it was as I said, I think it was between 20 or 25% of the total. Another example. So this is a little bit. If you ever, I invite you to look at the source code of OpenCV. OpenCV use this pattern a lot. So very often we need to work with the 2D matrices. So it could be a Jacobian, or it could be an image, or a grid map. From something like that. So it's a data structure that we use quite a lot. So usually the way you access, you have an API like this. So usually a very easy to use API. Say, okay, you will access a certain element of your matrix using the X and Y. Easy peasy. So this is a particular position in this matrix. This is another position, the same position in another matrix. The problem is that, or not really the problem, I mean, the intrinsic limitation is that under the hood, basically the way you find the index in your memory array is this one. So under the hood, behind this operation, there is a multiplication and an addition. So now you can see that, as I said, under the hood, we have, let's talk about the multiplication. We have 3 multiplication for each pixel or cell, as you want to call it, of the matrix. A better way to do it is to remember that according to this formula, if I don't change the column, then this portion is always the same. So what I do is to save this offset in memory, and basically split this operation in this part that is done only once per row, and in this part. So basically reducing dramatically the amount of multiplications that are done. So that's an example of something that, and actually you will not see. So, and this is a real example. So I cannot, this was a proprietary code, so I cannot give you more details, but actually that was a bottleneck in our operation that was doing, that was taking a big chunk of the CPU. So number 5, and we are almost done. So sometimes you just need to change the algorithm. So of course, all the changes I suggested are small dirty tricks you can use, but you will never have a better improvement than having a different big O complexity. I mean, if you have a linear algorithm and you change it for a logarithmic algorithm, of course the logarithmic version will be faster. Or if it's big O1, of course big O1 will always win. So sometimes you need to think in terms of big O complexity. If you have the luxury of if you're able to do that, or sometimes you just need to find a better implementation of the same algorithm. So this is a contribution I'm very proud of, because it's PCL, the point cloud library, that is very popular, and voxel grid is probably one of the most used filters in PCL. And once again, I had no idea at all about how voxel grid was implemented. But just profiling the code, I said, hey, I don't know why, but it's taking a lot of time. He's spending a lot of time doing this operation. I have no idea why. Now, months later, I know what the algorithm is. But what I think it's very nice that without even understanding the entire algorithm, I could say, you know what, I can just look for a more efficient way to do this operation, and that was luckily there's an implementation in Boost, and without even considering to rewrite the entire algorithm, I can get a very nice speed improvement. And we get to the last slide. So as you have seen, this is not rocket science. Actually, I was joking that maybe someone is a little bit, I don't know, unhappy or let's say, okay, but I expected something more from this presentation. Actually, this the core of this presentation is use tools, find good tools and use them. This is really what makes the difference. It's not just about using vector or an ordered map. It's really about learn about the tools, use them very aggressively, and you will learn your own rules. So you will have your own success cases, and even if this everything I mentioned seems incredibly simple and maybe boring, I'm telling you, I mean, I've seen this kind of issues in many popular open source software, and also, or even production in companies. So this happens. So even if it looks simple, sometimes you don't to have a measurable impact in the speed of your application, doesn't need to be super complicated. Say that if you're really passionate, as I am, about performance, there are other more advanced topics like cache-friendly and data-driven programming, single input, multiple value operations, SIMD, and of course, maybe there are some algorithms that can be can go faster in the GPU. Be my guest. so that's it. In short, is a little bit of what I learned and things that worked for me. So I think we can move to the questions if there are any.
Thanks, Davide. It was very good. Yeah, we can start taking questions. So right now I'm allowing everybody to unmute. Simply, if you have a question, just feel free to unmute and ask it. Unless you don't want to be recorded, then just type your question in the chat and I will read it to Davide. You should be able to unmute yourselves now. Yeah. So maybe I will start.
Everybody is sleeping.
Yeah.
No question.
In this example for optimization, I forgot what it was, but I was wondering, do you know the amount of CPU that you saved or amount of time that you saved?
Well, you need to tell me which one because it was the
Yeah, can you
Velodyne, the RealSense. Yeah, I can.
no, it was the proprietary one.
Yeah, they can open library or the matrix.
Matrix, yeah, this one.
The matrix. That was. I think it was 3 times. That particular routine was 3 times faster.
3 times. Wow.
Something like that. Yes, because basically the whole cost was really multiplication and addition, and the multiplication was reduced to a fraction. So 100% reduction in number of multiplication. So and that was really the bot. So basically, I think I can reveal more or less what it was. Basically, it was an implementation of the map layers that we have in navigation. So it was basically every layer is like a matrix, and you have to have a operation on top of the previous one. So that was taking really a lot of CPU, and because it was the bigger was the map, the bigger was the operation. And there was a lot of copies, but that was that particular routine was much faster. But then, of course, that routine was a smaller part of the total, so maybe it was 15% on the total of the entire application. But it's still, at the end of the day, that's the kind of gain you want. If it's 1%, 2%, you don't care. But if it's 10, 20, 40, then it's worth doing it. I have another one that I cannot share because that is a little bit just for fun. I'm going to mention it for fun. The Orbec 3D cameras. So basically, if anybody has ever used the Orbec, you will know that they use a lot of CPU, a lot. And I investigated, and as usual, okay, let's see where this is used. And it was used in a proprietary library. So the driver was free, with the exception of a single function that was proprietary. So in GitHub, you will find the binary in the GitHub, the precompiled library. And I discussed it with Orbec and said, hey, why don't you release it open source? I'm going to help you. Look, for free. I want to help you to optimize it. And they said, no, this is a super secret intellectual property. We cannot release this code. And so what I did was to reverse engineer, to the reverse engineering of the algorithm. And I had a version that was the total amount of CPU used was half, so 2 times faster. And I never released the code because since they didn't want it to release it, and I contacted them and said, hey, I have a version that is much faster than yours. If you release it open source, I will give it to you. And they said no. So I don't know what was the logic, but yeah, they said, no, we prefer our slow implementation.
And that's an interesting anecdote. We have Yasfant who raised his hand. Maybe, yeah, go ahead.
Yeah, I have a question. Can you hear me?
Yep.
Okay, good. First of all, thank you, David, for this nice presentation. Lots of things to learn in quite small amount of time, but really good. And congratulations for nominating in DrawStaff Award also.
Thanks.
Yeah, and also like I've been following you. You have been working with Blue Ocean Robotics, and your team has also won this MedTech Awards in this last few months before. So yeah, my question was regarding, as you have been a perception lead since so long, and I think also you mentioned you are one in the C-grade company now. So I would like to ask, like, how do you analyze the sensor configurations for robot? in your sense. Like, for example, if you have a robot and you want to have sensors, lidars and cameras and stuff like that. So as a software architect and as a robotics lead, what are the tools that you use to say like, hey, this is the right thing for this robot to have like this number of sensors and stuff like that?
Okay. Okay. Well, in general, of course, there is alpha. half, let's say, okay, 1/3 of the work is being old. So the fact that since I worked so much in robotics, you kind of know who are the usual suspect. But actually, we also spend quite a lot of time in at Blue Ocean Robotics doing benchmarking of 3D cameras.
Okay.
So there was a phase in which we purchased one of each. So the four, so RealSense, Mint Eye, Orbec, and there was we had to consider price, we had to consider and we tried to add a benchmark of how they behave in different conditions. And we found that RealSense has a little bit more noise compared to Orbec, but it seems to work a little bit better. This seems to work a little bit better when there is a shiny sunlight. And something that I recommend, a practical suggestion I have, when you do this kind of comparison, if you really, really want to have a consistent result, mount all of them simultaneously on the same rig and record simultaneously all of them. Because, maybe you record a Rosbag with one sensor in the morning and then another Rosbag in the afternoon. The light is slightly different. So my suggestion is purchase these components and if they're cheap enough, mount them all together and record exactly the same scene with all of them simultaneously, so you can really have a side-by-side comparison. Of course, if it's an expensive 3D LiDAR, you cannot do that. But on the other hand, when a sensor is more expensive, also, in my experience, it does what it claims to do. So in my experience, cheaper sensor, there are a lot of corner cases in which they may work or not. So the worst case, you wasted the $100. But when you are in the range of price of a Velodyne or of a RoboSense or something, in the thousands of dollars, at least they do what they promise. So I haven't found a huge difference between them. Then, of course, I don't know if you are talking about also force sensor or other stuff like that. So that is a little bit more complicated. But yeah, that's was more. So yeah, benchmarking. Don't trust the don't trust the marketing.
Yeah. Okay. Yeah. Nice. Thanks.
No one else will go. I'll ask a question as well. First of all, thanks for the talk. I enjoyed it quite a bit. One thing I've seen in a lot of, I guess, the self-driving industry so far is that no one actually, I think cruise automation is pretty much the only user of ROS in their actual cars. And I'm sure this is for many reasons, especially due to the fact that I guess the amount of memory copying that's in ROS is going to be a lot different than something that you can build custom for your own system. Do you think that ROS 2 really is going to solve this? Or, I mean, if you're shaking your head now, do you think it's actually a problem that people
No, I'm very excited about ROS 2, and it definitely solves some of these problems. So it is from that point of view, it is already doing the right thing. So there is already implementation of transport with shared memory or in-process message passing. There is in the roadmap work to also avoid the serialization, because deserialization for certain objects like point cloud and images. So it can go even faster in the future. I would say that Foxy is the first release of ROS 2 that is usable. And still there are some pain points that seems to be solved in Galactic. So I would say that Foxy is the first usable version of ROS 2, in terms of feature and stability. And I really think it went in the right direction to ROS to be used in the industry.
Great, thank you.
Maybe I have one more. If there was someone who wanted to learn about optimization, would you recommend some resources apart from your blog?
Sure. Yeah, I can tell you. Of course. So I think that in the C++ community, something happened in the last years that is super nice. That all the major conferences has the video online. So basically, if you just go to YouTube and look at the CPPCon or CPP meeting, and there is another one that is very popular. But if you just stop with CPPCon, the last 5 years, there are so many resources. So if you're passionate about programming, I really suggest that you look at that, and you will learn a lot. So and there's at the end of the day, there's no magic trick. I mean, as anything in life, if you want to be good, you need to study, right? So something that I do sometimes, when I go to the gym, I bring my tablet with me, and I put it on the conveyor belt, and so while running, I watch a CPPCon video. So it's a great resource for learning, and it's free. So yeah, I suggest that.
Krzysztof raised his hand. Go on.
Hello, I have a question related to optimizations, which actually will end in behavior tree. So if we want to optimize, we want to optimize some infrastructure level of code or a low level code. If we have something related to navigation, manipulation, or firmware, whatever, something on in the lower half of the code base in terms of how close it is to the user, we are going to be interested in optimizing. But at some point, we are interested in taking tasks, scheduling those tasks, and running high-level operations which manage the robot. Usually at that level, we are not that much interested in optimizing anything, but we are interested in keeping control over what we do. So first of all, is that a good idea to radically separate the components which are meant to be efficient from components which are meant to manage the robot, and the latter is not supposed to be efficient? And then what would you use in order to manage the robot? What languages, what tools? I mentioned behavior tree. Of course, I expect you to be biased in that case. And if you could...
No, but it's a good question. And the reason why I created BehaviorTree.CPP is just because I don't know Python. So it was a very selfish. So that is reason number one. And reason number two is that you usually... a lot of our code is written in C++, and you need start creating, interfaces and wrappers between Python and so on. So task planning. So behavior tree and state machine, we can call them task planning. That is what you mean. Usually you don't, with few exceptions, usually don't care about low latency, because usually you have something, of course there could be exception, but it's something like, okay, if this happens, then do this. If you reach a goal, then open the fridge or whatever. So who cares if that takes 1 millisecond more to be computed, or even 10 milliseconds or 100? We don't care, because usually task planning, a task in task planning is something that takes a lot of time to be accomplished. So switching between one task and another is not super fast. On the other hand, very often you need reactivity. Reactivity means that you should be able to interrupt a task that is being executed and do something else. An example is detecting a collision, or maybe you know, I worked in a project in which we had a robot that need to move in a vineyard. So going point to point was maybe 1 minute. So they said, okay, if you send a command that is 1 minute long, that takes 1 minute to be executed, you don't care about the CPU, of course, but you care that if anything happens that abort the action, you switch fast to a different task. So behavior tree and the state machine are a good abstraction to do that. As you said, that particular part doesn't need to be fast. And actually, I would be really surprised if that any implementation, even in Python or whatever language, if it use more than 1% of the CPU, I would be very surprised. Because usually that is something that is executed. There's a little bit of logic that is executed asynchronously, not in a loop. You're not processing algorithms, you know, processing data there. So yeah, agreeing with you, it is something where performance is, I would say, irrelevant compared to the ability to express your workflow in a way that is intuitive. So that is the requirement number one, not performance. So when I built BehaviorTree.CPP, it was just because I wanted to use CPP code in a more direct way, not through Python, not because I wanted it to be fast. Say that, I've tried also to make it fast, because if anybody wants to run it on a microcontroller, technically they can, but of course it's not a requirement.
Can I ask a follow-up question about behavior tree? Mm-hmm. It seems to me there are completely different architectural ideas about this management level software in a robot. You said you could write a bunch of Python scripts which manipulate via some binding low-level components which may be written in C++. You could call functions, you could send messages. There are a lot of options for organizing Python together with C++. You don't have to use Python. You can use some other scripting language. Yeah. You can write that in C++, but there is this behavior tree. It fits somewhere in between. It's not a scripting language exactly, but it's not C++.
Oh no, it is. It is.
Well, it is C++, but it feels like a different programming language that currently use XML to actually write code.
So,
okay,
so let me. XML is a scripting language. In this case,
I mean, it introduces a different way of writing a program. It's not like you, for example, you don't have exceptions in behavior tree, but you return status codes. So it's like a different language. I understand that it's implemented in C++, but you know, Python is also implemented in C. So it seems to me a little bit one notch higher level than C++ itself. Now, what is the application for this behavior tree? Is that, how is the project going? Is it being developed actively as we speak? Does it find usage in the industry, and where would you recommend to use it?
Okay, so first of all, about the scripting or not scripting languages. So first of all, your but is my, what you say but is what I say why. So what I mean is that the goal of behavior tree is to express a domain specific language. So then I used XML, but it could be something else. But the point is, you want to rise the level of abstraction and have a clear separation between task planning and implementation of the task, a very strict separation. And you want a domain specific language that is not a normal programming language, that by definition, a domain specific language is something that has limited capabilities, but is more expressive to solve a certain kind of problems. So Of course, you can write your behavior. The behavior of a robot could be a bunch of if then else, right? I've seen this. I've seen this in startups. The logic of the robot was to write if this, then that, then that, then that, and having 6 level of indentation of all the possible. This is not maintainable. So you want to have a language that, in my particular case, is the language that I express as behavior tree as XML, but it could be a language I create myself, right? I can embed my own language, but the point is that it is a specific language that is not good to compute A plus B equals C. Is not a general purpose language. It's a specific purpose language. So this is about, and then about the fact that it's maintained. Yes, I'm trying to maintain. I try to maintain it. I'm the only maintainer right now, and unfortunately, I do it in my spare time. But it is stable. So I have there are 2 parts. The Groot is I must confess is abandonware. Groot, I have absolutely 0 time to maintain it. But the core behavior tree is maintained, and I try to maintain. And if you don't see new features, it's because I don't need them. So if anybody needs them, can reach me on GitHub. And about the fact that it's used in the industry, I'm aware of companies that use it. I don't know how many, because they don't call me to tell me that they're using behavior tree. So I have no idea how many companies use it. I know a couple that do.
It's though, if I may again ask a question, it is though a popular idea in robotics, isn't it? Behavior tree itself. I'm not talking about one particular implementation, but the idea as such.
Yeah, I think it's popular. It doesn't deserve to be. So I think that is more popular than it deserves, because I have the feeling that as a community we haven't found the the perfect silver bullet yet. State machine has their limitation. Behavior trees has their limitation. Don't get me started with the more cutting edge, automated symbolic planning, where that is not usable in practice. Very interesting, but not usable. So I have the feeling that in terms of research, someone need to come with a better idea. But yeah, it's quite popular right now in robotics.
Thank you.
Yeah, I think we are officially over time. But Davide, I don't know what's your schedule. Do you want to keep going if there are questions, or should we end it at
If
that?
we have any, I am not in a rush, but I don't know.
May I ask a short question?
Sure.
Concerning the tools you mentioned, you said you don't like this easy profiler thing because you have to put some statements in the code. But after that, you said you like the Google benchmark thing where you have to put statements in the code as well. So I'm confused a little here.
Yeah. No, don't be confused. The point is about at the end of the day, it's about make your life easier, right? So what I meant in that slide is that why should I use an intrusive profiler if I have another one that is not intrusive and works super well? So that was my point. I can use both. It's not a big deal, but the other one works so great that it became my default option. This for all application profiling. And look, it has a limitation. It has limitation that it tells you where you spend time. So sometimes if you have an application that sleeps a lot or block a lot, you see, and that is normal because maybe you're waiting for a certain event to happen. So you're asleep most of the time you're sleeping. Then perf will not tell you anything interesting. You say, oh yeah, you spend your 99% of your time sleeping. What a interesting result. So in that particular case, perf is not a good tool. And Google Benchmark is something completely different. It's about identifying a small portion of code, or maybe even a big portion. So sometimes what I do, I'll give an example. Sometimes it is easier for me if I want to integrate this with a continuous integration. It's easier for me, instead of running perf manually, it's easier for me to add a Google benchmark where I put a certain input and I look at how much time it's taken to receive the output. That is faster for me. So I use both. So perf is about finding the particular position in the code that takes time, and Google benchmark is about easily benchmark a small or maybe even big part of your code, maybe an entire class. So actually I say that I used it on my entire pipeline of point cloud processing. So that was not a small amount of code, that was an entire class. And so what I was doing was to say, okay, let's compare. And actually I did that for the PCL case. So I had the two implementation of the voxel grid, one that was the official one, and the other was mine. And it was much easier to compare them. So whenever I say, okay, this is 20% less or 20% or faster or whatever, is because Google benchmark is really good at running it many times and giving me a statistics. So there are two complementary tools. They're not one against the other.
Okay, got it. Maybe a follow-up on that. So, but the Google benchmark statements, they stay in your production code, right? Or are they somehow optimized away with some compiler flex?
You create a specific in the same way, you have think about it, your algorithm, right? You have an algorithm encapsulated in a class.
Yeah.
And then for the ROS node, you've wrapped this class in a ROS node, so that does this computation. Or you can take this class and put it in a unit test. That is what you should do. You do a unit test. Or you can take this class and use it in a Google benchmark. So here we have three different processes. One is the real one used in production. The second is the unit test, and the third is the benchmark. And they all use the same library, but you generate with the same library, you generate different processes that do different things.
Okay. It's more like a testing framework. Okay, now I got it.
Yeah, think about use it in the same way you would use a testing framework.
Okay, thank you.
For example, and now I do have my follow-up. So, for example, I like to write code in a way that it doesn't depend on receiving messages. So I usually have a method that where I can inject directly the input, and then I wrap it inside the callback of a subscriber. So if I'm testing, I can just access directly the method, the low-level method, and I don't need to send a message from a ROSBag or something like that. So I don't need the inter-process communication.
Okay. That would be a nice blog entry for you.
Yes, you're right. Design patterns. Actually, that is something I'm planning. Design patterns for robotics. I need Matt. Would you join me in this effort? I need some.
I'm not sure if I told you about this, but I'm thinking of a project. I even bought the domain. It was supposed to be named Architecture of Open Source Robotics. So
great.
If this sounds interesting, we can talk about it at some point.
Yeah, I have a question about behavioral trees. May I?
I'm muting you, Matt.
Yes.
Go ahead, Rafael.
Okay. Yes, I think that behavioral tree is great. I discovered it last year, and we are using it a lot. Thank you, thank you very much for giving this nice tool. But also, since the last year, I'm also learning symbolic planning. So so we have a lot of.
Are you in
stuff.
Madrid, perhaps?
No, no.
Okay.
I am.
I know that in Carlos III, there are a lot of research in there.
I'm in Südtirol. And we have a lot of things done with behavioral trees. So so we have all the infrastructure to use behavioral trees, and we would like to integrate that with some plans generated with symbolic planning. That kind of stuff. I would like to know if you have tried to do that, and or if behavioral trees were were programmed thinking in this, or are completely orthogonal.
I would say that the idea is something that I think makes sense. There's no reason why it shouldn't work, but no, it's not being my, let's say, research interest. I've never explored this idea myself. You know, when I did this project, it was funded by a European, you know, one of these H2020 projects, and I really tried to do my best to, you know, say, I don't know if behavior trees are the solution to all the problems, but I know that I want to implement the best possible behavior tree library. Say that, as I said before, I have this feeling that it is a nice behavior tree themselves, not just my implementation, have their own limitation. And for sure, what you mentioned would be something very interesting from a research point of view, but I don't have any experience with that.
Okay, thank you. Because we had already a discussion in my team about what to do with this, and yes, I'm proposing to some kind of interface to generate an XML like behavioral trees and use that with our infrastructure. But thank you very much.
All right. Do we have anyone else with any questions? Because I think it might be your last chance.
Yeah, I think dinner is calling me. So
okay.
Okay, it's time to go.
So
okay. Thank you, Matt.
Yeah. So thanks a lot, Davide.
Everybody.
Yeah, and have a good dinner. Bye.